program in the College of Computing. We didn't do one this year, but we typically do an annual hackathon at UCI. We also do different workshops. We've done like regression workshops before and Git workshops. You can connect with us on any of these sites. I would say Meetup is probably the place to follow us because that's where we announce our events. But we've got GitHub with all of our presentations and materials. This presentation will be up there tonight. Actually, it's already there now. We've got Slack. The next event we've got coming up is May 15th. It's a lightning talk event, something a little new. We have a sign-up sheet that we will be, I think, publishing in the next couple days. So yeah, if you have any presentation at all that you are excited about presenting, I mean, it doesn't need to be code, it could be just conceptual, 5, 10, 15 minutes. We're going to try and do lightning talks for about an hour and a half. So if you're interested, definitely let us know. And just look out for the sign-up sheet as well. All right, so a little bit about Kareemdeep Singh. He's the Chief Health AI Officer for UC San Diego Health and the Joan and Irwin Jacobs Chancellor Endowed Chair and Associate Professor of Medicine and Biomedical Informatics at UC San Diego. Dr. Singh oversees AI strategy and governance for the health system. He leads AI initiatives within the Jacobs Center for Health Innovation. He completed his internal medicine residency at UCLA, where he served as chief resident, and a nephrology fellowship in the combined Brigham and Women's Hospital and Massachusetts General Hospital program. Kareemdeep completed his medical education at University of Michigan, the medical school there, and holds a master's degree in biomedical informatics from Harvard Medical School. So thanks for coming on.
With the thing, is there a mic I should use or just be loud?
No, yeah,
Awesome.
it will pick you up.
That's refreshing. So thanks for having me. Before I came here, I was at the University of Michigan for a number of years on faculty. What I'll do is I'll start off by talking a little bit about kind of how I got to this role and how I came across R and started using R for kind of a lot of stuff. And then what I will do then is take you into kind of what led me to look at Julia as a language in general, and then kind of try to recreate tidyverse in Julia. So it's mostly story mode. I do have some slides, but like the slides are not critical. So I think I'll probably look at some websites. I'll show you some stuff, and then I have a Pluto notebook pulled up, which is the Julia like hoity-toity like Jupyter equivalent. Now Jupyter supports Julia, but like Pluto is like built for Julia, bespoke. So I'll pull it up, and if we want to do some stuff and analysis on the fly, we can, just to show you kind of how it works. So in any case, like I said, it's awesome to be here. I got my start in programming, I think when I was like 8. My dad was a computer scientist. We ended up not learning any of the same languages. So I think the only time I ever like sat and coded with him was when I was like 8 or 9, and we wrote like some Pascal code. And I remember at that time the code ended with end, and then you had to put a period at the very end of it. And interestingly, part of Pascal was popularized by UCSD, which I came to know much later. There's a UCSD Pascal. But in any case, I was always like, that was kind of my hobby, was coding from very early on. My dad used C++. We used to get Dr. Dobbs' journal, which is like an old like series where you could like read about like, oh, like here's how to implement ray tracing. And it's like, oh. So I really wanted to be a video game programmer. Was specifically what I wanted to do. So I was always interested in like, all the like Doom engine, Quake engine, Unreal Engine, like that was, Cry engine, Crysis. And so that was always my like kind of hobby and happy place. So I got to high school. We had a lot of debate with parents around like, should I do engineering? I liked bio and I liked medicine, although none of my direct family members were medicine. And I remember one of the economic downturns, my dad had been laid off, and he wrote the networking like TCP/IP protocol that was used by a bunch of banks. And he lost his job, his company got shut down, and around that time, I mean, we really had a family talk that like, he's like, you should keep writing software, but do not, at that time, in that environment, that economy, like don't do software as a career. I was like, all right. So he's like, so in other words, you can become a software engineer after you do medicine. I was like, all right. Which is not an uncommon conversation to have like in an Indian household, but this was like especially true. And like, yeah, my grandma would hear it. It's like, no, you cannot become a software engineer. So I didn't stop writing code. I actually, in undergrad, released a program called Kpod. It was so iPods had just come out. Not the like cool iPods, but the like iPods that had like a little circle thing that you could use, and there was a screen, there was no internet, but you could plug your iPod into your computer with a USB cable, and you could mount it as a drive and copy over text files and read them on an iPod, like back in the day. So I figured out, wouldn't it be nice to read your email, which on your iPod, because you're like on the go, and like that was a thing that you couldn't do. So I thought about this idea for a while. I saw that someone had written a Mac application to do this, and so I decided to learn PHP and Visual Basic and make a Windows app to do this. And so originally it was like sending stuff to the web, it was like super not secure, and then I figured out how to run the PHP locally and have PHP talk to Visual Basic through shell and like through standard out, and got this whole thing working, and it was like super secure. It ended up being on Macworld magazine. It was like on their CD. It was like in a bunch of books, and so this was like probably like nowhere on my CV like would you really know this, because it was like one of the random things that I did as a hobby, but it got like tens of thousands of downloads, and so I was always like a problem solver with code. Like I had an issue, I'd solve it with code, but it wasn't like I was going out trying to learn how to code. I think I took one intro to programming class in all of my career. But just was always like a reader, always going to the zero section of library and picking out whatever new language was there, just like scanning their stuff. So went to undergrad, went to med school at Michigan. When I was a senior in med school, like at fourth year, we had these pagers that we carry, and so I figured out the API to our pagers. And I had this like grand dream to like run a prank where like all of us are in a lecture hall and we all get paged at the same time. So I thought, that was written with JavaScript mainly, but I think I might have had some PHP in there. So I filed that away. I was like, okay, I'm not going to do that. Like I don't want to, what if a patient like needs actual page sent? That was a delay because my prank was like going on, but this whole like plan. So then after that, I did my internal medicine residency at UCLA. And when I got to my fourth year of internal medicine residency, I was chief resident, and now actually we needed to be able to send pages out to all of the first years and all second years and all third years, because we had talks they had to attend, and we had like events they had, and so I had to like tell them, here's the events you have, and the pager made sure that they got the event, and the chief residents always sent this out at 8 in the morning. So I asked the chief residents when I became chief resident, how do you guys send that alert? And they said, here's what you do. You open 2 Word files. One Word file has the list of pagers, 7 on a row, because that's the maximum character count in the web interface. And then you have to page 100 people. And so then the second Word document is your page. And then you just copy, paste, copy, paste, copy, paste. And I was like, I don't want to be chief resident. Like, no. Am I going to waste half an hour a day doing this? Like, well, it doesn't take half an hour. You get good at it. It takes 15, 20 minutes. And I said, okay, that's not for me. So I resurrected my prank script because I realized they used the same thing at UCLA that they used at Michigan for paging. And in 2 weeks, we had a UCLA mobile health app that the chief residents could log into and use it to send pages. And everyone could use it to send pages, but the chief residents had a special, bulk page capability, which made my life easier, but was just one of the ways in which I was really kind of still in solve problems with code while also practicing medicine. And when I remember looking for mentorship in that wasn't a thing you could do. I remember talking to a lot of people, and I remember interviewing med school and saying, I want to write code and do medicine. And they were just like, that's not a thing. Like, like FYI, it's not a thing. I was like, well, it could be a thing. And now it's like a common thing. Now it's super common for CS majors and other folks to come through and do medicine. So made my way into fellowship, thought I was in nephrology, and finally got introduced to the field of biomedical informatics. This was like a big moment for me because it was the first time someone had put a name to the thing that I actually like to do, which is like computer science and computing more broadly, but applied to healthcare. I was like, oh, that's the thing I want to do. I was like, well, one, do I need to do the thing? Like, what do you actually teach there? And they teach a bunch of stuff I didn't know, so I was like, okay, that's helpful. They also teach some light coding. And so for the first time in, I think, 2012 or 2013, I took a course where someone spent part of the course and showed R code at least. It was like, here's how you do it in whatever there's like a Australian ML suite that's fully GUI based. I can't remember the name right now. Weka. So they showed us like ML and Weka. They're like, if you want, you can do some R. Like, here's an example. And I was hooked. And I was like, at that time, I downloaded R. This is pre-tidyverse, pre-dplyr. So it was either plyr, base, or data table. And so, it was like a mix of all three. Because at that time, people were doing mixtures of all things. I don't think I learned data table yet because that was always kind of like a dark art. So it was like plyr plus base R, what I was doing. Had a lot of going back and forth between R and Python. Because my thing was always, how do I do this in different languages? And I'd actually written, like at one point I wrote a RJS package where you could add R code into a tag in HTML. It would call the, what is it, Jerome Ooms, what's the thing he built? Like CPU, open CPU. And so it was like a server that runs R code. And so I even got it to, you could write HTML and your HTML tags where you assigned it a class of R would get sent off to open CPU and like return the output and populate your HTML. So for a while, that's how I was populating my CV with the Google Scholar. It was like, I used the Scholar package and I had a whole automated thing where it would like live generate my CV off of Google Scholar for the papers. So that was kind of always my hobby. I was like doing that. And I remember one time I was trying to reshape data. So I think it was like it was pre-tidier, but this was like cast and melt. I forget what even, if that was part of Plyr or where that came from.
Reshape or Reshape 2?
Yeah, Reshape 2, yeah. So thank you. So so I was doing cast and melt, and I tried that in pandas or whatever the Python like solution was at that time, and I couldn't get it to work. And that was the day I said, screw Python, I'm using R. Like, because I've been going back and forth. It was like, and R truly, So at that time I made the decision to use R, and in my second year of my master's, I kind of really discovered data table. And while people view data table and dplyr as kind of very different, they both use non-standard eval. And that was the first place I actually really encountered non-standard eval. So this is where you can just write column equals and the calculation, and the thing just works. And it knows that you're talking about a column in your data frame. It knows it's not like an object. That whole thing to write like really compact code, I don't know if folks have used it here, but that like hooked me. So I wrote most of my master's stuff during my master's, all in data table, then joined the faculty at Michigan in kind of this basic science department where I was at that time the only MD. Like it was all PhDs. I think it was a computer scientist. There was like an informatics trained person. And so I was going to teach an exploratory data analysis class. And I decided I was going to teach in R, even though we were teaching other stuff in Python and other things. So, fast forwarding, I actually designed my course in data table, and then for the first time really dug into dplyr when dplyr had come out. It still wasn't tidyverse yet, so I still remember first year or two of me teaching it, I had to be like, okay, now download ggplot, and now download this, and now download that. And it wasn't until my third year that I was like, oh, they like figured this out, and now you can just do install packages, tidyverse. But in any case, I think that that was a kind of a revelation, and I looked at dplyr and I said, this looks a lot less concise, and so part of me really didn't like it. But then I had learned SQL, and so part of me was like, wait, this is just like SQL but written in order, like in the correct order, in the way that I think about it. And so, and when I looked back at my code like a month later, I realized looking back at my code, with data table, I'd go nuts. I had like bracket, 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 bracket. I was not like, let's do one thing on a line. It was like, let's get this done. And so I looked back and I was like really not sure what the intermediate state was at each of those brackets in my head. So I ended up having to recreate those. I'm like, so you comment it out, it's super painful. And then I remember dplyr and going back to my code a month later and saying, I can actually tell you exactly what the thing looks like in my mind, not having like done the code. And if there's an error, having just looking at the code, I can tell you kind of what's happening. So that was the moment that really, I decided I'm going to teach my course in dplyr. So I actually never taught the data table version of my course. It started off as a dplyr course at the beginning. We would teach dplyr, tidyr, ggplot. I'd read Hadley Wickham's ggplot book, so that was the first time I actually understood ggplot. Because up until then, ggplot was equivalent with Stack Overflow in my mind. It was like, do this thing? Okay, let me go to Stack Overflow and see how to do the thing. And I read his book and I'm like, oh, that's how the mental model is. Now I get it. So I stopped using qplot, switched over to using proper ggplot. And so, we taught that tidy models wasn't around yet. So we taught, I think, MLR. MLR was kind of the closest thing to tidy models, what it eventually became. MLR3 then basically was like the next iteration of MLR, because all the tidy stuff is like 2, so they like went from 1 to 3, and skipped over 2. But MLR3 was like much more like scikit-learn and Python, and then tidy models came out, and I was like, finally, I have like a way to continue my course and teach modeling. And so, we would teach all this stuff with tidy models, and so the last quarter of the course was a semester-long course in Michigan as a grad course, was tidy models. So happily ever after, doing things fine. So let me start off with slides and show you kind of where things went from there. So when I have a Julia audience, the first thing I have to say is like, what the heck tidyverse is. But does anyone in the room, and don't be embarrassed, not know what tidyverse is? Okay, awesome. Thank you for raising your hand. Here's what tidyverse is. Okay, so tidyverse is a collection of data science packages that each do different things. They kind of pick off one thing. They're useful for working on data frames, and if you're not sure what data frames are, think Excel sheets. That are 2-dimensional structures where columns have a specific meaning. It's like age, it like tells you what the rest of the thing's about, and then rows are essentially instances of whatever that thing is, just like most Excel spreadsheets. So prior to tidyverse, these packages had kind of existed individually. So dplyr came out, which was to take a plyr and mess with your data frame. So transform your data frame, add columns, recode columns, to do aggregated operations where you reduce multiple columns down to one, use grouping so that you could kind of reduce specific groups down to one. So if you wanted to say, in this room, I want to know for like men and women, what is the average age? You would do like group by gender or group by sex, depending on what you're looking at, and then summarize and then calculate the mean age. Eventually, dplyr forked into tibble because this also didn't rely on R's native data frame, because R's native data frame printed in a really annoying way. So rather than try to fix that, we said, well, we'll use tibble. And data table had a nice way of printing too. So tibble eventually became its own package. There's a paint company in Michigan called Tribble. So every time I would see them, I would think of the Tribble function from Tibble, and I had multiple pictures on my phone of like Tribble because I thought it was hilarious. But Tribble was a way that in your code you could define a short data frame, which was useful for examples. Reader came out, and Reader was like how you read CSV files. Read.csv, which is the base R way of reading, would convert strings into factors by default. And so it was like a thing that you would learn your first day of learning R was set strings as factors equals false. And it was like lowercase s and capital A. Like you remember like all the camel case of like how to actually write that. And so this brought all these functions that just worked and had the kind of default settings that you wanted, and they were noticeably faster. And so that kind of was awesome. If you wanted to reshape data, that used to be reshaped too. Tidyr brought a very tidyverse-like series of functions. All these things are moving targets. Like Tidyr, the staple of Tidyr used to be gather and spread. And then one day it was like RIP gather spread. Now it's pivot longer, pivot wider. And Hadley was very clear, we're not getting rid of gather and spread, we're just superseding them, which means we're not going to touch them. I think now they're probably like on their way out. But in any case, at that time when it was first announced, it was like, oh crap, all my code from the last like 10 years or 5 years is not going to work. It's like, no, don't worry. Categoricals are super annoying. There's a whole book called R Inferno. I don't know if you guys have read it or not, or come across it. Google R Inferno. It's all the stuff that goes wrong in R. And literally half that book is about factors. But it's like over 100 pages, so it's not like it's more lengthy than actual how to learn R books. And so it's a nice, it's really available online as a PDF. Stringer for dealing with strings, per for doing iteration stuff, ggplot for plotting. This is just like subset of it. There's Haven, there's like all these other packages that are part of this. So anyways, there's something beautiful about this kind of ecosystem because everything just works together. And there are some kind of rules of the road. You put a data frame in to a function that's supposed to modify a data frame, it will spit a data frame back out. And so there's like kind of things that you know to expect, which is not always true of base R functions. And the other key thing that I didn't have on here is Magritter, which introduced the kind of initial tidyverse pipe, which let you pipe things together. And I think it's synonymous with dplyr, because I think it was like, you'd never use dplyr without it. But that was kind of another key thing that wasn't there at that point. Now we have kind of base R pipe, but that means of like a 4.2 or 4.1 and 4.2 in the placeholder. But that was kind of a key thing in R. So here I am, like dedicated R user. My brain still thinks in R, and I was kind of following languages and seeing what's coming out. And I came across this benchmark by Matt Dowell. Matt Dowell is the creator of data.table, a competitor to dplyr, at least in, I would say in his eyes at least, and probably other people too, because it often becomes like one of these like online battles where people are like, I use this one, I use that one. So in any case, he was working for H2O, which is a company I love because I used all their AI stuff when I was in R. It was agnostic, so you could have a H2O frame and access it from R to Python simultaneously in 2 different sessions. So it was awesome from my standpoint for some of the stuff I wanted to do. And so he puts out this benchmark, and I was like, what the heck is dtplyr.jl? So on a 5 GB data set, this was at that time the fastest way to work with data. Data.table was fast, for this set of tasks, 15 seconds, whereas this was 9. And for that same task, dplyr was 175 seconds. So this, I would say, is kind of like whatever. Like you can wait a few extra seconds. It's not a quality of life thing. This is a quality of life thing, I would say. Now, this is for maybe extreme workflows, but I mean, the things I was thinking about were kind of not extreme, but I mean, 5 GB, not like a crazy size of data set. So you can only imagine kind of what the 50 GB one was. And data.table actually came out on number 2 or at the top for 50 GB at that benchmark. So this was an expensive benchmark to run. He ran it a couple times at H2O and they stopped running it. It's currently maintained by DuckDB. And weirdly, only they have found Julia to be crashing and like polars to be crashing. And somehow they're like number 1 and everything else is like slower or crashing. And so it's a little suspect right now in the current version of it. And even on Julia Slack, people are talking like, we can't recreate that error. It works fine in RCI. So there's some weird thing there. But
really? I just feel like that should be an issue file for them.
Oh, it is. But they're just like, hey, it doesn't work. And they have no incentive. They only update it when a new DuckDB version comes out. So this is like, there'll be like there'll be like 6 months that go by, there's no new benchmark. And clearly updates have happened. So it's always kind of like whoever runs the benchmark, you can fork it and like you can run it, but it's like the actual benchmark machinery is actually written in R because it's still Matt Dowell's code. But all the other stuff is different. And there's a lot of specific rules about what you can and can't do. So they've tried, it's nice because they've tried to really make it fair. But in any case, here's the initial version of that benchmark in 5 GB data. And so ignore the fact that things are written out like in a kind of ugly way, like combine group by, like you can do pipes in Julia, all that stuff, but they just kind of wrote it that way. Of course, in R, they chose to write it with a pipe, but whatever. And you can see the kind of data table code here. And again, I would say, hey, this is non-standard evaluation, but whatever. So 2 things you'll notice. 1, Julia was fast. 2, this is the first time you run it, this is the second time you run it. And so it's like, why is it different? And actually the whole reason this benchmark has 2 bars is because of Julia. Because Julia actually is a just-in-time compiled language, which means you can run it in a REPL just like R in a console, like when you type and you get interactive code, except that the very first time you write a function, it takes a few milliseconds and compiles it. So that the next time you run it, it's actually running machine code. It's not running interpreted code. So the first time you ran it, it took a little bit longer because it had to compile. The second time you ran that same thing, it didn't have to compile. You might say, wasn't that cheating the second time? But you can change out the data frame. You can change out the arguments, and it still runs that fast. So the point was, it really is, it's not great for exploration, but if you're hardening a production workflow and you want to run something with a new data frame every time, you'll see the benefits of that in Julia. So this got me thinking, this is actually, I want to say this was 2021 in May or June. And so this got me thinking that and I was looking at Julia, I'm like, this looks a lot like R. This is not that different from R, so there's obviously differences, but big things about R are not different. So I had this kind of observation back in 2021, probably after I saw that benchmark, was that, it's 2024, R is now directly compiled into Julia, known as Rulia. There are those who use tidyverse, others swear by data.frame, and there are those who ironically use base Rulia. And what do you do? And so I didn't know that I was going to be the one to write the tidyverse. This was just like a funny thing that I kind of imagined at that time. So a couple things happened in 2022 that made me look at Julia seriously. Julia 1.8 came out. And for the first time on Mac, it wouldn't set fault. So they actually gave Mac on Apple Silicon full support. And up until then, you couldn't run it reliably on an M1 processor. And so it wasn't something that if you had a Mac was really the thing that you'd want to do. And so that was kind of a big issue. So this is Julia 1.8. Another big issue was that for the longest time, if you look about Julia older threads, you'll come across this thing called the time to first plot problem in Julia, where the first time you open Julia and you try to plot something, it takes 45 seconds. So why is it taking 45 seconds? It's not only compiling your code, it's compiling all the packages that your code relies on the moment you run your first line of code. So that's intractable. That's kind of saying, I have this super fast language for you, but the first time you use it, it's going to be 3 minutes. And you're like, okay, that doesn't make any sense. And any other line subsequently might also be a bunch of time because it has to compile. So if it doesn't have to compile, it's fine. If it has to recompile data frames on the back end, be prepared to wait a few minutes. So 1.8 started to fix this problem, and 1.9 fixed it. And now it's currently completely fixed, basically. So these are the time to load times and time to first plot. So what you'll see is going from 1.8 to 1.7 to 1.8 to 1.9, it's basically seconds at most, and in 1.10 and 1.11, it's basically not noticeable.
Were these improvements because of binaries?
So kind of. It's the closest thing to a binary in Julia. So in Julia, they don't distribute the packages as binaries. When you install a Julia package, it is compiled for the first time on your machine. It's faster than C++ compilation, so it's not clang, 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 clang. When you used to do tidyverse installation on a Mac, it was just so painful. So it's less painful than that. But this is the reason it works. They do compile it, but they cache that compiled code so you can reuse it. And they let package developers write pre-compilation scripts so that when you install the package, in addition to installing it, it would run that pre-compilation script. So you could just say, hey, run all of my functions once. And now that is adds a little bit to the compile time, but that's fine. I don't mind paying a penalty once. I mind paying a penalty every single session. So now it's like, now they're storing the actual binary, so to say, right, on your machine. They're caching it on your machine so that the next time you open Julia and you run code that relies on that, it's not recompiling it. So that's kind of made it actually, so I started learning Julia in December of 2022 over winter break. August of 2022, and that was when that update came out. And that was enough for me to say, now let me look. Because up until then, there's no point.
Yeah, you prefer questions as you go.
Yeah, whatever, doesn't matter.
Okay, so is there a framework in Julia similar to DevTools and Use This to make package development easier?
So package development is super easy in Julia. I would actually say there is a thing called package template, which helps you set up the structure of your package. It has an interactive mode, and it has like a thing where you can keep keyword arguments. So this is where you say, I want it on GitHub. Here's the GitHub location, and it like files all the metadata for that. After that, there's no overhead of like Roxygen and all that stuff that you need. Like all the examples and documentation are just doc strings right above your function. So it's like fairly straightforward to write packages, and package development and release is substantially easier in Julia than R.
Is there a local repository like similar to CRAN or PyPy?
Yeah, there's so there is the main general Julia registry, and for new packages it takes 72 hours to register them, and that's a time where the community can look and make sure your package name is okay, all that stuff is okay. When you set up a package through package templates, it automatically sets up GitHub actions that run CI to make sure that your package works on different versions of Julia. And then when you update a package, it's 15 minutes. So if I update a package and to release it, what I do is in my commit after my after my CI passes, in my comment to my commit, I tag the Julia registrator bot. I literally just say like Julia registrator bot register. If there's a breaking change, I have to write like, here's the breaking change, because that's a new thing they instituted as a quality control measure. But then I hit enter, and I like go to work, and then like 15 minutes later, the package is on the registry. So there's a culture of continuous release. You fix a bug, just push a release. It's very different than CRAN culture, where you run into the wrong like CRAN reviewer. You're like, you just released something yesterday, why are you releasing me again today? So that's why our universe evolved kind of as a reaction to that. But Julia registry is the official registry. You can, of course, make your own registry, but that's the kind of official one.
So can you like make a private package that you don't have to publish?
Totally, yeah.
Okay.
Yeah, and so you can, there's ways to distribute packages that are private in the same way that you can make an R package, as long as it has package structure. Like you could zip it and send it. So yeah, you can have local packages. There's a lot of companies that internally use Julia. There's a big chip supplier that, like in the name, that uses has a bunch of Julia packages. They're all internal. There's a General Atomics in San Diego that runs like nuclear fusion reactors. They use Julia, so they have like internal Julia code. So not all their stuff is open source, but they have some. It's up to you, just like anything else. So what time is it? Because I'm probably like running.
7:43.
Okay, let me just jump to show you what it is, because I think I've given you a sense of like what it can do. I will show you
until 8:30.
Oh, wait, 8:30. Oh, okay.
So up to you. You can,
Oh, okay.
do an hour. But
cool.
we have the room until 8:30.
Okay. So if folks need to leave at 8, like or leave whenever, I won't be offended.
Oh, that's interesting.
And it's a conversation. Okay. So 2 things I'll show here. This is melanoma. This is what it looks like on the skin. It's an example. And I had this vision that I wanted to write a random forest algorithm that could do image classification. Why would you do that? Why would you not use a convolutional neural net? I was just like, I just want to do it. Okay. So I had already in my master's program written a JavaScript implementation that can do that by reading the raw image and like converting it to like a matrix, and super painful in JavaScript. So I want to use an R, and I want to do it as a random forest or XGBoost sort of thing. So what I wanted to specifically do was identify a split in a random forest. A random forest is a decision tree, then you do a bunch of decision trees. So identify a split, and then for the next split, I wanted to look 2-dimensionally in an image in a restricted area to find the next split. Normally, random forest, if you were to do an image, you would turn this into like a bunch of columns. Each pixel is a column, and then it could look anywhere. and it wouldn't have any sense of like where that pixel is. So I wanted it to do like a random forest where it went like outwards. So eligible splits were only those that were within a certain distance of the original split. It sounds crazy, but I don't know if you noticed, but Microsoft Connect uses random forests for all their pose detection. Microsoft wrote a book on this, and so I like have this. It's online. It's a PDF. You can read it. So this is not crazy. They talked about all their poses, like it's super fast. They're like, why is it fast? Because Connect doesn't have a big GPU. Like we run all random forests. Okay. How do you change the splitting rule of XGBoost? I'll tell you one thing. You don't do it in R. You go somewhere in here, and somewhere in this madness that is C++ is the split rule. And everything is object-oriented, so you have to learn now every single freaking object and figure out where is the split rule actually happening, which is the whole reason I'm like in R and not in C++. Okay. Then I hopped over to Evo trees, which is a Julia implementation of random forest. And here's that. Looks like our code, kind of. It's like for loops and like greater than, like. So this to me was like, oh, I could actually use this. So that was kind of one thing that clicked. Another thing I was mentioning early on was, which I forgot about, was my wife is a primary care doc. She was put in charge of like designing schedules for their clinic, and so I had written my code in R. It took 20 hours to do because it was a bunch of for loops that were sequentially building data frames, which you're not supposed to do because it's memory hog. And I wrote that same exact code in Julia, like almost no differences, just line for line translated, and it ran in 20 minutes, and we found a schedule that worked. And I was like, all right, if you want to do general data science stuff, R is awesome. But if you want to do anything cool, this is the official recommendation. And so I actually have this book at home by Dirk Edelbutel on writing R with C++. But this was one of those like how it started, how it's going. So then I kind of, once I figured out that I could write this and make it go, in 20 minutes in Julia, I was like, I could sit here and learn C++ and Rcpp, or I could just switch to Julia. And so I ended up trying to switch to Julia. Why do I have this here? Oh yeah. So I told you, dplyr is slow, like at least historically was slow. And I think still on benchmarks is slower than data.table and some of the other things. But along came Mark Fairbanks, who put together a package called tidytable. Tidytable was essentially data.table, but you were writing tidyverse code. And it would translate all the data table eagerly, and it was pretty darn fast. So this was like the revelation moment for me. But I was like, this is what I want. I want something that wraps data table, and it's super fast. And since then, he also wrote dtplyr, but this is actually still simple to use. dtplyr, you have to collect, you have to know what you're dealing with. Here, you just, as long as the data table, it just works. So I said to myself, could I replicate this in Julia? So January of 2023, like this 1 month into my learning Julia journey, I got this working. It's wrapped in a function because I was benchmarking it, so ignore the kind of function definition. But tidytable.df, exactly our code. So how does this work? This was 50 lines of Julia to implement this. And the reason it works, that is the entire dplyr replicated in Julia by cheating. And the cheating here is that I take this, I convert it into a string, I open R, I run it in data table, I bring it back. But here's what's cool. To implement that for every single function, I can write, you can use metaprogramming. And so I don't have to write a select function, like a group by function. I can just loop over all the functions and say, I just want you to do the same thing for all of them. Boom. And this is the entire dplyr right here, and this is the entire pipe. It started off much longer, but I figured out as I learned metaprogramming in Julia that, you can just have code that writes code, and it works. And if you're wondering what the heck is the @ sign tells you that before Julia looks at this expression, Julia gives you this expression and says, do whatever you want with it. And then you can do whatever you want with it. So you can convert this to another expression. Like, this is not valid Julia. I can convert this into valid Julia and run the valid Julia. So that's what's kind of happening here.
Oh wait, sorry, so what are we seeing here? This isn't Julia, this is the
This is
code?
Julia.
This is Julia.
Yeah, but this is wrapping tidytable in R.
Oh.
And
got it.
tidytable is tidyverse wrapping data table in R.
Okay.
So this is like, you know, the whole Julia is supposed to solve a 2-language problem. This is like a 4-language problem. I'm writing Julia to call R to call C, because that's what data table is written in. So it's all kind of pointless, but it works.
So it's like a little transpiler, so it reads in year greater than 2000.
Yeah.
It
Transpiler is generous. It literally is like, it's like literally like, okay, do that thing and then add a pipe to the end. And then, you know, and then at the very end, don't add a pipe because you can't have a trailing pipe. Yeah.
How does it actually interface to R? Is there an open R session?
RCall. So
This just
using
uses
the
RCall.
RCall package, when I say using RCall, it opens a session at R, so that it's a persistent session.
And it leaves it open.
Leaves it open. And then anything that's in a string that's prefixed by R is R code.
And it'll save all the objects in that session.
And I can access the objects from that session. Just
Yeah.
like a reticulate, but from Julia to R.
Nice.
And this is also string magic. This is like a special type of macro that gives this to a function that can run that. So you can write, in Julia, you can write these kind of string magic things yourself. So this is not a special, they didn't get special permission, it's like anyone can write that. Just like you can write infix operators in R with a % sign.
Mhm.
So it's like totally legal. Cool. So this was called tidytable.jl. I wrote it in January. I benchmarked it, and of course I benchmarked it wrong. So it apparently sparked a 250 reply chat, or 150 reply chat in Julia Slack, unbeknownst to me, because I wasn't on Julia Slack. And so they very nicely filed a GitHub issue to like indicate that you're not benchmarking it correctly. That's why you're finding your implementation faster than Julia, and like here's actually the correct way to benchmark it. So I said, fine, I appreciate that. Thank you for that, I'll fix it. And so I was like, yeah, I was mostly just messing around. I was like learning it, don't take me too seriously. I'm just trying to figure it out. And I was like, you know, I like the existing, there's a data frames meta and data frames macro packages in Julia that are kind of like tidyverse. They're kind of dplyr-ish. But I said, I wish there was a way to run so in Julia, one thing I should say is, in R, you have to decide, does your function run on single values or on multiple values? In R, everything's a vector. But there are functions that accept single values, where you have to write lapply or map to run on multiple values, or there's functions that run on a vector already. In Julia, you can always write a function that runs on a single value and add a dot at the end of the function name when you call it, and it vectorizes it. And so in data frame meta, you had to always decide. There was a separate macro for vectorized and for unvectorized. So if you want to do a weird thing, like I want to subtract a value by its mean, you have to think, like, well, which one do I use? Because mean, you don't want to vectorize it, you want one value back. But when you subtract two vectors, you want it vectorized. You want it to be done element-wise. We call it a Hadamard product. So I said, okay. So I wish you could do this, where you could run a devectorized version of a code and then vectorize only the parts of it that you want. While most times I want rtransform, which runs a function one row at a time, so it's row-wise. If I'm standardizing a variable as an x minus mean x, then I need to remember to use transform. That's more of a Julia-style thing, which is borrowed from MATLAB, than anything specific to data frames. Otherwise, I'm loving Julia. That's the one pain point that I hate, is I have to remember where to put the dots, and you have to put the dots everywhere. Equal sign, like less than sign, not equals is like dot not equals. So it gets like really annoying to write code. Okay, anonymous replier here says to me, who actually wrote one of the other Julia packages, not the one I was wrapping, but one of the kind of, now I would say, other packages that has a similar kind of function focuses tidier data, which is Julia has no way to detect if a transformation should be done column-wise or row-wise, unfortunately. You can't vectorize a function the way you do in R, but it might make sense to make it row-wise the default and introduce a new function. And I was like, no, that's not what I want. So that made me super mad. So we're in January, like end of January. So fast forward like a week and a half, and my first commit of Tidier.jl was born. And the first thing I wrote was a auto vectorizer that could figure out, should this function be vectorized or not? And the key thing there is, you can effectively write code that looks like R code and Tidier.jl will abstract away whether to vectorize or not. You shouldn't have to worry about it. And that has a lot of added benefits. And the benefit that it has, which wasn't apparent to these guys, but was in my head, was we now have tidyr.db, which is a full-on reproduction of dbplyr. So you can use the same exact code and have it run on a database. Because in SQL, there's no such thing as kind of dot vectorization. So we were like, that's great if you want to only stick with data frames, but if you want to port your code to databases, it works. So tidyr.jl was born. It was originally just dplyr. Some people really rubs the wrong way in Julia, so I have to remind them that there's a couple myths about tidyverse to know. One is that people think tidyverse is just an R package, and I remind them there is freaking tidyverse everywhere. This is already outdated. There's like probably a dozen more. There's even tidyverse in Scala. But you know, it's all over the place, all over Python too, multiple implementations. People are like, oh, why are you bringing R syntax to Julia? Like, this is a question I get from Julia people. And I tell them, tidyverse is not idiomatic R code. Non-standard evaluation by default is very different from base R. And so that code probably looks completely ununderstandable to someone who learned stats in the 1970s or 80s and 90s. Like who first, you know, one of the like original OGs of R would look at this, I don't even know, is this R? Like, I don't even know what this is. And so we tell them, like, it violates many R norms. And so what we're bringing to Julia is not R, it's actually tidyverse. It's a very, very different thing. And piping, right, which was not a R norm until it became a base R thing because of the popularity of tidyverse. And then, you know, other things like first argument's always a data frame. Like, there's kind of norms that tidyverse set that are not R norms. What is tidyverse? Yeah.
Just a quick question. What do you call the data frame in Julia?
Data frame.
Okay.
There's a dataframes.jl package, and we wrap that package.
Okay, so one thing that when Tibble came out, I loved is that when you subsetted or did some ETL on a data set and it returned a one column Tibble, it was actually still a Tibble as opposed to a character.
Same thing.
Interesting.
Yeah. And there you can do drop equals true and get back so you're talking specifically about bracket syntax. With bracket syntax, you're right, that if you did bracket, comma, 1, base R would pull that as a vector, whereas Tibble would pull that as a column. I don't know if that's what you're referring to.
That's exactly what I'm referring to. Yeah, that's what I'm referring to.
But if you use pull and select, it was no big deal. Like pull and select was like whatever, right? But you're at bracket. So and dataframes.jl has a bracket syntax. I don't mess with that. So there is a bracket syntax similar to R in
but basically you just treat a data frame as a data frame.
Yeah, and I
Julia.
yeah. So you can do a bracket syntax very much like R, like 1:10, you know, comma. You can't just have comma nothing. You can comma colon, but it will actually return the first 10 rows of all columns in the same way that it would in R. Cool. So yeah. A lot of implementations, even in R. Like people are like, oh, well, tidyverse is not the only tidyverse in R. There's like a bazillion other tidyverses, at least when it comes to dplyr. Okay, Hacker News, like 2016. I thought I'd be using Julia today, but I don't have any of my like big, you know, any of the stuff that would let me work with small, medium data sets. I thought the same thing. The tidyverse ecosystem is so good. Like, why would I touch Julia? Julia coming from R, like, you know, I wish there was a, basically, like, I sort of, I know a spot of R, I'm told Julia is an extremely natural place, but I'm stuck. And then people have, like, literally asked, is there a tidyverse for R? And the replies always say use queryverse or use data frames meta. And guess what? Those are not full-on replacements for tidyverse. And so that was always an issue for me. And then, like, yeah, there's just like lots of these threads, and so usually things have just died. So why isn't there tidyverse in Julia? Julia functions have to be explicitly vectorized. So this is actually a line of dataframes.jl. This is a mutate function, and I'm saying if the value is less than 0, make it 0, otherwise return the original value. And store that in a new column named xnew. So it's mutate xnew equals if else, whatever. Notice that the if else had to be vectorized, because this is running one value at a time. And even the less than or equal to had to be vectorized. It's actually dot less than or equal to. So this gets pretty gnarly, and I just did not like it. This really bothered me. And similarly, if you're subtracting from a mean, you have to do transform, but then here you have to do dot minus, but then here you don't want the dot, because a mean is returning a single value, not one value per row, whereas a dot minus tells you to return one value per row.
And there's no way to auto-vectorize any given thing.
There is, that's what I wrote.
Okay.
So that was a key thing, is that's what the guy said is not possible, and that made me so mad that I like spent a week and a half to figure out. Let me just jump and just show you Tidier.jl rather than doing any more slides. Okay.
That would frustrate me
So,
too. Like NumPy auto vectorizes. Means you like multiplication.
cool. Here's the package on GitHub, and here's what we've got so far. So, and I'll show you examples of code, but it started off just as dplyr. And then once we got enough other functionality and tidier plots got a little bit more mature, we spun off dplyr and tidyr, tidyr, not tidier, into tidier data. So that's kind of implements tidyr and dplyr. Tidier plots is ggplot. Tidier db is dbplyr. Tidier files is essentially a combination of reader, haven, and Rio. So if you're familiar with Rio, Rio was a package that was it was at like Facebook who wrote it, like his name. You could just write import and export, and it doesn't matter the file type; it would just take care of it. So we have a read file and a write file, and as long as your extension matches what you want it to be, it just calls the write function underneath it. But we'll click on each of these because these each have documentation. Tidier cats is for cats. We have categoricals, and so it's tidier dates is liber date. Tidier strings is stringer. Tidier text, not part of tidyverse, but this is tidy text. And then tidier vest is rvest. And then tidier iteration is per. And we also have janitor built in. So you can do clean names and clean the column names of the data frame. We also have a bunch of other things built in that normally would be separate things. Tidy log is built in. So I'll show you like an example of tidy log. But
Wait, what tidy log is?
here's what it is.
Yeah.
You enable it to true, and now when you do something, it tells you what's happening. So if you like filter it out, it'll say filtered out this many rows, X% of your data, X many rows remaining. So in R, you have to install tidylog, which is a separate thing, and I almost always use tidylog because if you're in a research lab, it's the best quality control working with student you can have. Most errors you can spot in tidylog. They're silent errors.
Have you checked out Maestro?
Maestro?
Yeah.
I have not. Is that a?
It's a orchestration / logger.
So Maestro is the new Drake, right? Or no?
It's like a competing thing.
Computer, yeah. So that's different.
Yeah. Targets, I think, is the new.
Target, sorry, yeah. So that's different. There's Dr. Watson in Julia that does that capability, Dr. Watson.jl. But this is more like I'll show you a filter here. So I'm going to filter to.
I've not used tidylog, but I've tried log. I use logger a lot.
This is much more passive than.
It doesn't cause errors, yeah. So actually, let me do filter number greater than 100.
Can you zoom in?
Oh yeah, I'll put that. Sorry. Thank you.
There we go.
Yeah. So I'm going to do filter number greater than 100. Run this. What did I do wrong? Oh, number greater. Cool. So it shows you it removed 23 rows, 92% of my data, 2 rows remaining. So tidylog does that. It outputs what each transformation is doing to your data frame. In a really long pipe, you used to be that you either knew what went in and what came out, but you didn't know if there was an error, what row caused that error. So this easily makes it possible for you to say, group by added 2 groups, summarize did this, filter did this, And then we treat group by just like tidyverse. So it peels off one layer of grouping. So if you want an ungrouped data frame, you have to write ungroup at the end, just like in R. So this is actually this is a convenience thing. It's not actually to orchestrate anything. It's more so you're working with a student who's running code interactively or has code to show you. And I look at their tidy log as I look at their output to make sure, like, oh, why did you exclude 90% of your data in that function? Something is wrong, and we can spot, oh, you misspelled the thing you were trying to filter. And when you misspell it, that's just a common way of catching those kind of silent errors.
Python mutate joins too, so like see right away when oops.
Yeah, and we
Not
support it for
join
mutate, we support it for joins.
This
Yeah.
logging's really interesting. Take the summarize it. Still 25 rows, 3 columns. Where was that actually computed? Does it send extra code to the R session?
This is all in Julia.
Okay.
This is not sending anything to R now. So tidytable.jl was my cheap R wrapper. This is now fully,
This is all in Julia.
yeah, this is fully in Julia. Everything here is being translated into dataframes.jl code and running dataframes.jl code in the back.
Got it.
Yeah.
So what I'm wondering is, because you're converting like county, gender, you're converting those to strings representing the columns that you're doing this whole filter on. But what if you want to bring in like an external variable, like gender equals X, and that X variable holds
Yeah.
potentially F or M to represent that? How would you not confuse X with a column? You know what I mean?
That is a phenomenal question. I'm looking for where I document that. We solve that with interpolation.
Okay.
And there's 2 ways to do interpolation. And I am just looking for, I might be in this one. Let me just see what I can. Utility data, do I talk about interpolation here? Yes, okay.
See, like I do SQL
Yeah.
in Python, and this stuff comes up
Yeah,
all the time.
So let me run this notebook and make it live. So Pluto notebooks are reactive, so they take a little bit to run. But what's cool is if you update any code cell, every other code cell knows which code cell depends on which code cell, so it will automatically run the code cells that need to get rerun, just like Shiny, but in Pluto. There's a version of that in Python called Marimba or something, or there's a Python version of that concept also. But that's why it takes a little second.
So is it like targets where it only runs?
Yeah,
whatever?
exactly like that. But it's within a notebook. So you
Okay.
can write scientific code in a notebook and it still behaves well because it doesn't actually necessarily run it in the order you wrote. It runs it in the order of dependencies. It reads and that's all metaprogramming. It's all written in Julia. So it reads your code, figures out what depends on what, and then kind of constructs it automatically for you. So, okay. So what if we had today's date, which is sitting as where did I put it? Let's see. Today's date. Yeah, so I compute today's date right here. Yeah. And I want it's now its own thing. And I want to interpolate it into here. In every other Julia package, they don't use non-thread evaluation. They actually use symbols to refer to column names. So we broke a major kind of Julia convention by saying, screw that, we're going to write non-standard evaluation. So what you do have to do, unfortunately, is you have to interpolate it. So there's 2 things you have to do right now. When I rewrite the parsing engine, a lot of this stuff will just work. But you have to add an eval at the beginning, and then you have to prefix the thing that you're trying to insert with a $.
Oh.
That tells you it's pulling it from above and not from here.
It's like an escape,
Yeah.
kind of. Okay, interesting.
We actually support so in R, the way you would do this, well, R has dynamic scoping, which Julia is a different scoping thing. So in R, if you were running a function, right, you'd have to do parse enquo business, and then you'd have to do not, like 2 exclamation points in a row. We actually support that. It's just I have to fix the parsing engine so it works for all edge cases. But that's the goal: is we'll support R style bang bang operator. And in fact, if you go to the tidier data docs here, and you go to interpolation, we actually show you that you can do. Let me make it bigger. you can essentially do R style, not, and that tells you point to something outside. So my bars here is this, or it's something else. And you can even do multiple things. So in R, you have to do bang bang or bang bang bang, depending on if it's a group by and a dot dot. Like there's a whole thing. But in Julia, we got it, so it just does this. So how does this work? Well, I read this expression, I detect that, I surround this with an escape, and that points it to something outside of the data frame.
So this is also for using variable column names, right?
Say that again?
So in R, and I've just started learning this myself, the
Yeah.
double curly bracket notation, the curly curlies,
Yeah.
so that you have a column represented as a variable and passing that to a tidy expression.
Where I've seen it, yeah. So that is curly curly is a thing, but curly curly, I think, is more it supports less. I want to say one of the syntax is more powerful than the other, and I want to say bang bang is more powerful. There's certain things curly curly doesn't support, and so I didn't bother trying to do curly curly.
But it's the same goal.
Same goal, yeah.
Yeah.
Except here in R, as long as it was a object defined outside your data frame but in the same scope, you wouldn't have to do not. R would check the data frame, see that column doesn't exist, and then go to the parent scope. But in Julia, I can't dynamically do that.
Yeah.
The way metaprogram is implemented, I can either change the expression, or I can peek inside the object. I can't do both at the same time.
Another reason why the bang bang is used in R is if the same name is used in the data frame and outside,
Yeah.
the bang bang explicitly tells you to use the outside one,
Yeah.
because it will default to using the inside one.
Yep, and also there's the dot. There's the dot data. There's another way to denote that too.
Yeah.
Yeah.
What? Yeah, I feel like that went away for whatever reason.
What, the dot data?
Yeah.
I mean,
I
possible.
use it again, but yeah. So inside of a mutate function.
Yeah.
Um,
Let's go to mutate.
Okay. And because where I end up getting into weird dplyr issues is specifically with like the bang bang stuff or the curly curly. But like in R, if you're trying to create a new column and you're assigning the name of that new column in like an R-ling sim, and then you're using the bang bang something
Yep.
equals, you've got to use the colon equals.
Yes. You have to
Okay.
use the walrus operator.
Right.
Yeah.
Is that a thing in this version of Julia?
So as long as you use the eval and $ syntax, you can use it anywhere.
So okay,
it
what's the
works
dollar
even with the
syntax
mutate.
again?
This thing equals, and this thing could be pointing to a string that to something that's defined elsewhere.
So the $ just means it's not in this environment or this.
$ is used to interpolate things from outside. So before it runs the code, it first inserts that thing, then it runs the code as is.
Okay. Thank you.
But you as a user have to use eval. I can't build that into the code because you have to mark it because it has to run in your scope as a user.
How do you write a function? Like if I wanted
yeah.
to write a dplyr function, but a Julia function.
Yeah, so programming with
Yeah.
So it's the same way, except you would have a look. We could try to write it if you want to try to write it.
No,
But what you would do is you'd have an argument, right?
we have Julia at work, but only like 5 people use it. So
Yeah.
now I'm like, you know what?
There's an argument, right?
Might as well ask the library. creator, right?
Instead of saying bang bang, you would just write $, and then before your chain you'd put eval, and then it would work.
Okay.
But you can use it in functions, and we've confirmed that. Like, because that was the key pain point was the old way that interpolation was implemented with bang bang was relying on global scope, and now it's whatever your local natural scope is. So now you can do it inside of a function. I know it sounds so. Actually, I actually think we have it in documentation somewhere, for where you actually do define it in a function. But we have a lot of docs. So I'll just give you I'll just click and just show you the high level of what's implemented. So let me go down here. Here's all the stuff that's implemented. In just dplyr and tidyr.
Do you have the slice functions?
Huh?
Slice?
All the slices are implemented. Slice,
slice
slice min,
sample.
slice max, slice sample, slice head, slice tail.
Oh, okay.
How dare you question?
How big is this weed?
Okay, so here's we. Yeah, so here's slice, 5 rows. We have negated slicing, right? So negative syntax works. Slice head, slice tail, slice proportions, like the first 1%. Same thing as like everything supports proportion or number, just like R. And then highest, slice min, slice max, with ties, without ties, all that stuff is supported. So here's the we. The we is, it's me, one of my med students who now is a resident, and in between calls, will push like updates on GitHub. Like he'll be rounding and he'll like, wait. He'll push an update, I'm like, wait, aren't you at work? He's like, yeah, I had a few minutes between patients. And like, and he actually learned Julia purely off ChatGPT. So he wrote, he had texted me to say, I wrote some packages in Julia, but I don't know how to make it into packages. I was like, what packages did you write? He's like, I wrote lubricate, stringer, and forecasts. And I was like, when did you do this? He's like, in the last 3 weeks. And I was like, but dude, 3 weeks ago you didn't know Julia. He's like, I know, I made ChatGPT do it until it worked. And like, there were some edge case issues because it's like, you know, not written by a human, but it like, we've gone back and fixed a bunch of stuff, and so it does work. Yeah.
So there's something I was thinking about with regards to vectorization. Like a lot of the time when you're writing like a SQL script or something, you do membership, right? You're like, let's say you have a